All right. Hi, developer friends. Thanks for joining us today for our Gemalto session here at the Intel Global IoT DevFest. We're very excited to be here. Me, that's Manny from Munich in Germany, and my colleagues in Berlin, that's Simon, Jürgen, and Jose. We're going to talk to you today about how you can create mobile IoT applications using our 4G LTE development kit for rapid prototyping. And it's really exciting times in the IoT, and the world is increasingly connected, and it's offering a huge potential for new digital services, and is, of course, in need of developers like you guys out there to actually make it happen. So I'm actually, a techie at heart, but I turned to the dark side, so I swapped my development tools like Eclipse or NetBeans for PowerPoint. I'm heading the marketing team, but also in charge of the developer community. Here at Gemalto, and that's a marketing part, I have to tell you this very briefly. We are all about trust in the technology, making it reliable, but also in the secure software part, where we're serving like 6 main markets where this is deployed to secure digital exchanges for peoples and things. And we're actually in our IoT division, where we want to create an internet of trusted things to connect, secure, and monetize your IoT solutions. So connectivity is where we come from, where we offer wireless modules and terminals, industrial-grade rugged SIM cards, subscription management solutions to manage the life cycle of your application, but also very much about security and monetization, which I think could be very interesting for you developers out there, because you want to make money with your applications. So licensing options, we also have that in our portfolio. But let's keep the marketing part short, just to give you an idea of where we come from. We've been in the market for a very long time. Like, we've invented the first M2M cellular modem over 20 years ago. Actually, we were the first to embed Java into a module. That was in 2003, where we really started embedded processing. Nowadays, you would probably call it edge computing. And in the hands-on demo by Simon, you will actually see how this can be done, how it works. And this was about the time when I joined the company, and I did my first client-server-based project, where I still did some programming myself, actually. And from the modules, we've come a really long way. We started with really basic modules, but now we're in an exciting time where we have really dedicated technology for the Internet of Things, machine-type communication with LTE-M, narrowband IoT on the horizon, things like that. And we also offer hardware and enabling technology, as you can see in this slide, but we're going to share them so you can check this out yourself. What I want to show you today, and actually this is the main content part of this session, is how we can actually make your life easier as developers, how you can kick off your design with development tools that are Intel based, actually. This little baby, our Connect Shield, was sort of co-developed with Intel. We launched it last year at Mobile World Congress, where I snapped this pic from the Intel booth at the top right. And it's really a nice tool for you to get started, where you have everything in a box. Basically, it's a Arduino-style maker board that features LTE Cat 1 in this case. And it's really easy to get started, and you will see with the demo by my capable colleague Simon how easy it really is. It looks super easy when Simon does it. You will see. So it comes in a package with a printed antenna. Just add a SIM card, some Arduino shields if you need particular sensors or something, or from SD Micro, as you can see in the demo, and then you're good to go. You can program on this baby with Java. So if you want to take a closer look, we have main antenna, even antenna diversity, USB port, lots of interfaces, programmable buttons, and you will see a lot more in the practical demo. It's part of our developer journey that we can enable really from idea to hopefully big business at some stage. So you can, when you have the idea, you can really rapidly build your proof of concept using our Connect Shield or concept board. That's a bigger variant. You can add it to any cloud-based platform. And yeah, build your proof of concept in no time. Then when you want to actually go and test it with real people, you can actually take the software that you've developed with Java and put it on a terminal, which is fully certified. Go live with that terminal, test your device, get real user feedback. And then when you're done with the testing and you know your idea will work, you can actually then go and still, put the software that you've developed on the module, take this module and build, do a bespoke design, a cost, size, power optimized solution. And yeah, we can support you along the way. And we love our little development tools. I've developed a lot of our own use cases with that. I really loved our tweeting dartboard, because when we showed it at Mobile World Congress, I got to play dart all week. That was awesome. Or Horst, the tweeting pot plant that would call for when it wanted watering. We actually did a developer contest where we said we're going to build any idea within 48 hours, and the winning solution was this bushfire alert system from Australia, which we actually built and showcased. Some friends over at Ericsson, I believe, they joined the Bosch hackathon and built a connected chainsaw, because you can probably. And also at the telecom booth, this reminds me of Ted, this naughty teddy bear, right? But they did a connected teddy bear even, right? So you can do lots of things. The sky's the limit. And with that said, I would like to hand it over to my friend Simon, who's sitting in Berlin, and can actually share the setup for the development tool chain and how easy it is to use.
Great stuff. Thank you ever so much. As Manny said, we have a variety of boards, of development boards. There's this one, which is a 2G and 3G development board, but that's not the topic of today. And there's this one, which is does have a cable sticking out of it because we'll be using it. And this is the 4G, 2G cellular board, which can run Java applications. We can run Java applications on there. It has 30 megabytes of flash file system, 20 megs of RAM. So it's not incapable. It's got quite a lot of space on there. And some of the tools that you can use to write the Java applications to run on the module are Eclipse or NetBeans. And today I have NetBeans open on my computer. And there are a bunch of projects here that we've done. And what we find when people are looking at these modules, they want to talk to the industrial interfaces on the modules. So the industrial interfaces might be the serial ports, the first or second serial port on the module. They might want to send AT commands to control the module, to configure the module, send SMSs and that kind of thing. But also these devices can respond to external stimulus. So they have GPIO inputs and GPIO outputs. So we have handlers for these kind of things. And of course, the modules want to stay on the network. So we can write software to ensure that they deal with all sorts of network outages, as you might be used to with your phone, toggling your phone in and out of airplane mode. And we have I2C on this product as well, so it can talk to I2C devices, and that's part of the demonstration that we'll show you today. And lots of people are interested in location for where their modules are. So the modules can be geographically placed in a country based upon which mobile country code they're connected to, obviously. But if we look at the cells that they're connected to, we can get a rough position within a kilometer or two of where the device actually is. And some of our products, although not the one that I'm going to show you today, have proper GPS or GLONASS positioning as well. So we have GNSS products as well. For the demo today, we were asked not just to show SMSs going in and out, because SMSs are a little bit old-fashioned now, but we were asked as well to have a look at MQTT. So this demonstration will show data going out to an MQTT broker. And if you're familiar with MQTT, that's fine. If not, MQTT is a really nice, lightweight protocol designed for applications that will talk over wireless networks, not guaranteed networks. And yep, there's an SMS handler as well and a subscription handler. So these are some Java classes which I find myself reusing all the time, and therefore they're a common group of Java classes. They're what I use in all the projects, and this particular project is for the Connect Shield, as Manny was introducing it to you before. So with the Connect Shield, we don't need too much more. We've already got all of the plumbing here for the demonstrator. We need one more class to start and stop the application, one class to capture the external device. And I don't know if it was clear from the slides before, and I don't know how good the quality of this picture will be for you, but on this device, there are some LEDs flashing. You can probably see there's a temperature sensor, a light sensor, and these kind of things. So we represent that as a class within the system, and then these different sensors, the LED I2C extender, the temperature I2C monitor, and the ambient light sensor are then 3 Java classes. And so with these classes, we can build an application to run on the module. Of course, we mentioned MQTT before, and MQTT has a number of open source implementations, and the one that we have ported to our module is from the PAHO project. If you're familiar with that, the PAHO project 1.1, I think it is. And this MQTT that we ported here, there's quite a lot of code there actually, but that MQTT library allows us to talk to Amazon AWS, to Microsoft Azure, and various other cloud systems. In this particular demo, we won't be talking to any of those. We'll just be sending to a broker and having a look at the data coming from the broker. Okay, so this is the sort of software we have, and if you wanted to have a look, we don't have too much time to go through it, but this is just Java. It's just standard Java, Java ME, the mobile edition of Java. Yeah, so I can build my common library. I can clean and build that, and it goes off and we'll build that library, and my laptop fan speeds up. Okay, so we're just going to build that library. That's pulling in the MQTT as well, so it's building quite a lot of stuff there. And that's finished. And I can then just build that little part that is the demonstrator itself. That pulls everything together. And when we write things in the IDE, we get and something that we can output. We get something that we can send to the module. There are debugging tools, but they can be a little bit complicated. So also it's quite easy to just go straight to the built parts. This is where the source code for the demo is. This is what we just built. These are my backups in case it all went wrong today. But these are for your average Java demonstration or Java application. We have a metadata file which describes the main application, and we have a jar file which is the application itself, and we simply copy and paste those from our PC to the module. The cellular module is connected to the PC, and when we have a look at that, you'll see that it has 30 megs, well, 29 megs of flash file system, of which we've used a couple. And here's the demonstration. So we could copy and paste the demonstration in there and run it. So we can build applications, copy them to the module, and using a terminal emulator, if you guys are familiar with cellular comms and using terminal emulators, then you can use TerraTerm, or in this case, I'm using an old version of Zoc. But this is the application running. And we can control the application. This was obviously one I built earlier. but I can install, with this AT command, I can install the application that we built and copy to the module. And with this AT command, I can run it. So if I send a 1 and I ask the module to start again, then it will start running the application. Won't need that one again. So this is the Java app starting up. And what it will do is it will initialize the hardware on the module. It will check the module's serial ports and digital audio interface and so on are set up correctly. It will read some parameters from the JAD file, from the metadata file that we had. And then on the I2C, it will go and look for the hardware that we said is on the board. These are the 3 devices it's looking for, and it finds them. And the app starts gathering data from these devices, waiting for its network registration and setting up a couple of other things. And what you can see happening here is the perfect demo effect. Is it not working? Which is great. Bear with me. That doesn't look like it's connecting to the MQTT. But if we're looking at I2C, we are reading data from the I2C, the I2C GPIO extender. We're getting temperature information, and of course it's not 32 degrees in the room, it's 32 degrees on the PCB of our shield. So we have room temperature plus a few degrees for the cellular module. We have the light, the ambient light sensor information coming in, and the status of the button. And I think we're not sending data to the MQTT right now. I got an error here. But that is the demo effect, isn't it? Bear with me just 1 second. Let's just try that again. So what I'm going to do is restart the module, and we will connect to the device again when it comes back up. And the app automatically runs. One of the nice things about the Java virtual machine is that it starts when the module starts. And if we install an application, we can optionally tell the application that we want it to automatically start when the module starts, which I've done in this case. You can see here we're waiting for the cellular network registration. This is telling us that we're roaming. Network registration is successful. We're starting some housekeeping timers and things like that. And yeah, that's great. So the Java virtual machine has threads that are running, and we have the network monitor, the connection manager, the location requesting thread you can see there waiting to start, and the MQTT thread. So all of these different things that are happening in the application can happen at the same time. They're all running at the same time. And we're getting the light data coming in here. If I were to move the shield and point it towards the wall, this way is the wall, and you should see the value of the light data going down, which is great. And if I turn it towards the window, then obviously the amount of light coming in will go up. So you can see the difference between the 500 light units, whatever they are, and 2,000 light units. And that was just to distract you, because in the background, whilst we were doing that, what's actually happened is we did get a connection to the MQTT server. This is our MQTT server here in Berlin, and we can see that the data connection is up, and we're now correctly connected to the broker, as we should have been before. I do apologize for that. And we can now look at the data. And I wanted to not have that running on my computer. I wanted to show you that on a mobile device. So I have my trusty iPhone. I don't know if you can see that, but we have an MQTT client running on the iPhone there, and data scrolling up on the MQTT. So the data is coming into this client. We have various pieces of data. It's probably a little bit easier if I just show you a couple of slides on what this looks like. If you bear with me, this is a similar slide set to the one that Manny was started off with. And if you are interested in this information later on, then you can see a bit more information about the shield and the components that are on there that we're talking to, with data sheets for them and things like that. And some of the AT commands you may have seen me using, these sjam AT commands, discussing the midlit file and so on and so forth. So there's some information there, and you can see how the the application is running. This is mirroring the sort of thing you would have seen here, going actually in real time. What we can do is send SMSs to the device. So I can subscribe to the device. I can, from my mobile phone, send it an SMS, and it will start sending me these similar sorts of readings that you saw before. So the I2C extender, the PCB temperature of the device, and the light readings, they were 0 in this case, and the button status was 0 in this case. And I can say that I want to get that data every 5 minutes, for example, and I can pick different topics that I want. I can subscribe to different topics. Very, very similar as you would see with MQTT. With the location stuff, we can either just look at the MCC mobile country code and say, yeah, we're in Germany, or yeah, we're in the US, or we can be a little bit more specific. And in this case, we're using a service from a company called Combane, just in this demonstration, where I can get cell-based location. You can get a free trial key for the Combane service from here, if you'd like to have a play with that. And the Combane website allows us then in our phone, in our mobile device, to send an SMS. And we should be able to get responses back from the device with a typical sort of Google Maps link, which we can then click on. And if we go to the module, you can see here that I've sent the module an SMS. It's received an SMS from me asking for its location, and it's set up the location, telling us that we're based in Germany, which is fair enough. And you can hopefully see that there, but it knows that we're in Germany because it doesn't know anymore right now. And I can then send it a key for the Combane service. And you'll see on the screen here, you'll see the key for the Combane service coming in. It's accepted the key, and it will now go off and do an HTTPS post to the Combane servers, wherever they are, and get a more accurate location for us. And so what will happen then, bear with me, I'm just typing on my phone very quickly, is that you can see that we're getting the request coming in. And on our mobile device, we should now get information about our location. Right, so now we get a much better location on our mobile device. It tells us roughly where we are. There we go. And it's not perfectly accurate, but you can see with the cell-based location, the red dot is where it thinks we are, the blue dot is where we actually are. We're within a kilometer or so of our location within Berlin. So we can do that kind of stuff. And very often people are interested about the health of the module, interested in which operator the module is connected to, the quality of the radio service, whether it's 2G, 3G, 4G, the signal strength, the error to noise ratio, the sort of temperature on the PCB. And again, we can get that similar kind of information as well on our cellular device as well with SMSs. So you can hopefully see that kind of information here on the iPhone. So you can see that kind of thing here. And sorry, I've lost my mouse.
Yeah, Simon, you wanted to show us which MQTT client you're using for the iPhone, right? Because we're going to have another MQTT game actually prepared, right? We are. So the MQTT client that we're using on the phone is here. There are lots of MQTT clients. Two that we found that were working very nicely were this MQTT tool, which I can show you in just a second. And there's another one here as well, the ICPDAS tool as well. So running those on a mobile device, game such as this, you can see this running on my phone here. And I've captured a couple of screenshots just to show you that kind of thing as well. We have similar messages to those that you saw with the SMSs coming in on the MQTT here, with the sensor data coming in as well, and the location information. And that information comes in real time on the device. So this information is in real time. I don't know if you can see it scrolling up on the camera,
as the messages come in. Probably not, you probably can't see that, but the messages come in real time. Each of these messages we can click on and go into a little bit more detail. So here, if I was to click on the location message, then I actually get the Google Maps location here in Berlin. And if I was to click on that module status message, then I get the same kind of operator information that I showed you before, including the modules ARN and things like that, the module software versions and things like that. So that is a demonstration of the shield, of our Connect Shield, and the I2C data being read from various sensors and being sent out to an MQTT tool. However, there are far more exciting things that we can do with MQTT than just boring sensors, Manny. And Manny, maybe I could pass back to you to show the next set of slides.
Sure, and we should also mention, by the way, that we will host that and post that on our developer community, right? So you can actually build this yourself, download the sample code, get all the pointers, and now we have Jürgen Gröde, who actually took this to the next level and actually built a Pac-Man-inspired game based on MQTT, right? So I'm going to show you quickly. So there's a test bed, right? And where you can control all those ghosts. You have the actual game, and you actually played this at a big workshop that we had with some developers in Berlin, right?
Thank you, Manny. You showed a big excitement about that. So we did a change on the microphone. Now Jürgen is speaking. And thank you, Simon, for giving us fantastic insights in our connection shield. It seems embedded Java virtual machine makes a quick pilot very attractive, and even writing a matured program is well supported on top of our engine. So what you see on the slides now is on the left side, we provide a testbed to all the team members who have to work and set up their game controllers and target their character in the game. So we put every character in the game in a little jail, in the little box, and the teams try to get control over it via MQTT. So when they finish and get control over the character, of course, we do the switch into the real game, and you can see that on the right side. This is the game all the team will play against each other. And of course, as you see, we take the famous Pac-Man game as guideline for our game. However, in our case, we removed all sort of artificial intelligence to let our teams to do the real work and enjoy the board game. So I mean to say, first, the teams has to set up their game controllers, and finally they master the game as a sort of reward. Teams have to operate the hardware properly and have to manage the Java code dealing with the buttons, the display, IP connections, and of course, the MQTT subscription. Yeah. So on this slide, you see we provide the MQTT broker and tell all the teams the name of the character and the topics the game controller have to push messages for the characters, and the topics the game controller has to subscribe to receive score updates or even some sort of control messages like start of the game, end of the game. So as we were looking...
What the game controller looks like, right?
No, please let us stay on the second slide, on the slide before. We jump to that later. So on the right, on the left side, you see our setup on the browser. So we decided to go with web-based technology and decided to go with the open source engine Phaser. And on Phaser, we found a tutorial which was a base for our game, where we spent all our work and efforts. So from my perspective, it seems to be a stable environment for this kind of workshops. Mani, let us jump into the third slide.
So this is what it looks, right?
Yes, this is what it looks like. So you see the OLED display, you see the buttons of a game controller, and you see our concept board. So let's let's go with that. You can see the concept board, which provides an Arduino-like socket and the right power level to drive the OLED display in a direct way. And you can easily find all the GPIOs you need to run even the enormous numbers of buttons we need to control our characters. So it seems now to be the right moment to spend some words about the team building process we did based on this game controller, because you can positively support if you split the game controller, the buttons, in the major directions. So we build up teams consisting of 3 members per team, and every team member was participating in controlling the character. So one drives the up-down direction, the other the right-left, and the third one was responsible to drop some stuff on the board. And the work split was also endorsed during the construction phase in the teams. So one can focus on the hardware setup, and the other 2 team members simply deal with the Java midlet, write the code, reading out the button states, and bring the code into operation. So my final remarks on that is, it helps a lot to bring people in an international team together, and everyone in our teams showed a very concentrated and focused behavior, because every team member was that much interested in participating in the final game. So I hope I could brought some excitement of this exercise across, and would like to pass the button back to Mani.
Thanks a lot, Jürgen. You guys surely had fun, right?
A lot of fun, of course.
I can imagine. Yeah, I want to definitely try it out next time I'm with you in Berlin.
You're welcome, Mani.
Absolutely. So I find it amazing. So when Jürgen and Simon show off with the development kit and setup, it all looks so easy. But actually bring an IoT solution to market, in fact, has many challenges, especially in the field of mobile IoT or cellular-based IoT, because you have to develop software on the device, you have to develop software on the back-end side. I mean, MQTT makes it easy because you can build on something that's standardized, but still you need to do the field testing, test the end-to-end solution, and to take it to scale. There are challenges, but you are not alone. We can help you there. And this is where I would like to hand over to Jose, who can tell you a little bit about the lifecycle management. So what do you do when your IoT solution is out there in the field? How can you manage that over the 5, sometimes 10 years or longer that those IoT applications sometimes are in the field? Jose, over to you.
Thank you, Manfred. Well, hello, everybody. And like you've seen, we're going to conclude by giving you a few hints or aspects you should actually look for when taking your idea from, let's say, prototype to the actual market. You know, when bringing your idea from the lab to actually making business out of it. And after your design has been, ruggedized, your hardware, you need to go and certify the hardware to market it in the target regions you want to sell your product. You have to think about some aspects related to device operations and this real world scenarios that need to be taken into account. There are actually 3 key areas you should look for when moving from prototyping to production as such. And they will play a key role in the success of any IoT application. The first one you heard already today, Gemalto is a company that provides trust. And we think that trust is the key element to help build an IoT application, basically securing end-to-end connectivity and communication. So basically making sure that your devices are sending data encrypted, but also that they have unique identities that are trusted by whatever cloud you want to deploy, and that the cloud can actually trust the devices. This is key, and it's the first step. But once the trust has been established, you need to make sure the connectivity is stable and reliable. Making sure that your devices communicate reliably at all times, it's another key element. And then once all this is set up, you need to scale. You need to be prepared to moving from, just deploying a few tens of devices or even prototypes to actually being able to handle tens or hundreds of thousands of devices in the field. And if you're successful in bringing your idea to market, this success will definitely bring along challenges. And some of the threats you'll see when you start to move from the prototype to the market are, for instance, cyber attacks. IoT systems are really becoming a key target. And you might have heard about hacked teddy bears, or cars have been hacked, etc. This is becoming more and more an attractive target to hackers. So you actually need to be thinking about it from the beginning. Then customer complaints. If connectivity fails, I mean, this is the last thing you want. Customers will call you and complain, and this you want to, of course, avoid at all means. Providing good customer care by giving or by preventively maintaining the fleet and the connectivity, so making sure that the problems are fixed, because the actual customers will complain due to let's say, a device that's not properly communicating is key. And then operational expenses, so basically sending, going to the field in order to fix devices, to change software, is one of the key problems our customers face, and you need to think about this from the beginning. So what we call device lifecycle management, these are the set of tools that ensure that you can actually deal with these challenges. Any IoT device management solution will help you take care of these aspects, these operational aspects, so you can actually focus on developing your own idea. And you don't need to think about those aspects. Any device lifecycle solution should bring along certain features, such as device identity, device provisioning services, the ability to help you enroll devices into IoT clouds, and the ability to help you diagnose connectivity, to repair issues, and also to optimize connectivity and connectivity costs, plus also the ability to help you manage software of devices over the air. So when you get a Cinterion module from Gemalto, what you get is a tool, what we call Cinterion Module Services, and that's basically a device lifecycle management tool that is built based on a component, a software component that's inside of this Cinterion module terminal, or the dev kits after you've seen today, that enables this connection to the Gemalto device management platform and gives you the possibility to manage IoT devices from this console. So if you look at the architecture of an IoT application, we'll look into how device management will fit into the picture. As of today, you'll probably be developing an application that's running on a microcontroller, or you're running on the Cinterion module, as you've seen today, on top of the Java virtual machine, and that be communicating with an IoT cloud through an MQTT or any of the other protocols that are popular today. And then you'll be building some kind of application logic on top, right? So if you add device management to the picture, and how we propose it is to basically enhance your system by device management component that will work in parallel to your IoT application, will complement your IoT application, and will make the management of those thousands of devices more efficient. So be able to manage the software lifecycle of devices on your behalf, either through a device management console, as you see here, or through a device management API. And the system is actually built in a way that there's no need to modify your own application, because the software component that enables this device management, what we call service agent, is built inside of the module. So some of the cool things you can do with device management are, for instance, things like device preventive maintenance. So looking into, for instance, if there are connectivity issues, being able to predict if there will be issues that are epidemics, or that you actually need to look for change in your design, or, for instance, during testing, or to be able to provide a better customer service through these tools, and also to being able to correct those issues by issuing or sending remote commands to the device and modifying configuration, modifying software, etc. You'll be also able to deploy software to thousands of units in the field with one click. So what we do is to provide a way to help you manage the module firmware, but also the Java applications like you've seen today. So if you want to actually test these applications in the field and you for some reason need to deploy a patch, the tool provides you a way to deploy patches automatically to thousands of devices in the field. So just to conclude, what we call device lifecycle management, that's module services in Gemalto, provides a tool that's embedded in the Cinterion module that's scalable, because actually it's embedded in the module, and it can handle very large fleets, so you don't have to worry about that part. And that's zero touch, because there's no need to modify your actual software, so it complements very well your application. And then it's smart because we use the device and information, and also the experience we've gained through the management of thousands of smart assets in the field. In Gemalto, we're managing millions of SIM cards through so-called OTA platforms. So we use these insights to help manage efficiently for instance, software downloads to devices in the field. And last but not least, security is in our DNA. And with the Gemalto solution, you actually get a solution that's secure by design. And with that, I conclude. I hope I help you at least think about some aspects that you need to work on when you're actually moving from prototyping to actual production, to selling your products and making a business out of it. Thank you.
Perfect. Thanks very much, Jose. That was a lot of information in very short time. What we tried to do for you is sort of explain a little bit this developer journey or developer experience that you can have using Gemalto products, really from the development kits like the Connect Shield, the concept board for your proof of concepts, but really also with terminals where we have a ready-to-sell, fully certified product that you can test with friendly users, to your cost-size, power-optimized, bespoke design. And then, of course, what Jose has presented to you, to be able to manage your devices out there in the field with campaigns where you can do software updates, where you can really not lose control. So we're, of course, very excited to see what you will create. And we do recommend that you let us know. One way could be if you want to join our Gemalto IoT developer community. So that's developer.gemalto.com. You can join the community. You can also find the code samples that Simon has shared on there. I'm not sure if Jürgen has put his Pac-Man inspired game there yet. Of course, you can also follow us through our website. We're on Facebook, Twitter, YouTube, LinkedIn. Do reach out to us. There is an opportunity, I think, right now to answer some questions. There's two very similar questions from Akash and Gopal, why we chose Java, and if the board also supports Python. Well, why did we choose Java? As we showed in the slides, we did this 15 years ago, and it's proven to be a very successful platform. It's optimized for size and processing power constrained devices, and with the embedded processing, you can of course leverage the fact that you don't need your own application processor. I mean, we also offer just modems that you can just use as a modem, and then you could have your own application processor. And this is, in fact, what you would have to do if you really want to run Python or C. Today we don't offer that on modules. But Simon, do you want to share some insights from your side? Do you often get this?
Yeah, we've had this kind of question before, and as you said, the cellular modules that we have been around since the late 1990s, really, and we've had Java on them also since that kind of time frame. So the Java engine goes back to late 1990s, early 2000s, that kind of time frame. And yes, back then processing power was very restricted. I think we started off with a 16-bit Java virtual machine. It was quite small. We had tens or hundreds of kilobytes of RAM and flash, and maybe 1.7 megs of flash. Nowadays, as we were discussing, we have much more powerful 500 megahertz ARM processors in there, 20 megs of RAM, 30 megs of flash. So the modules have become a lot more powerful over time. And the Java is the Java ME, the mobile edition. It's a fairly well-featured Java language. It's not like Java SE. It's not like you'd find on the desktop, but it's a pretty well-featured Java. You can write almost everything you want in there. It doesn't handle real-time communication, so we cannot do DSP processing. We cannot do deep packet inspection for IP packets. And we cannot handle real-time interrupts. Those three things the Java cannot do, but it can do pretty much everything else that you would want. So the Java language allows our customers to write applications in Java. So you might find gas meters or electricity meters or wind turbine monitoring stations, these kind of things with their entire business logic written in Java. So you can make quite considerable edge device intelligence in Java. The two questions that I saw were regarding, I'm sorry if I'm not looking at the screen, I'm just going to go back and look at the questions. One was regarding Python. Yeah, Python scripting is possible, not on our products per se, but I'm fairly certain you could find a Java application that would interpret Python, Python being a scripted language.
Oh, that's good. Yeah. Okay.
And why do we choose Java? Can we program this board in other language, Python or C? Yep. Similar thing again. You could probably find a Python interpreter that would run in Java. That's absolutely fine. C not. C would be compiled to a native platform and have to run on the same. It gets a little bit more technical, but the C is a more dangerous language to be running on the module. Our cellular modules tend to be built in two parts. There tend to be two sides to the module. There's like the radio side and the application side. And what we want is that the radio side remains standards compliant. It is a standards compliant 2G, 3G, 4G cellular module. And that radio part of the module must not be interfered with by a customer application, by a Python script going wrong, or a Java application going wrong, or a C application going wrong. And the easiest way for us to do that architecturally is to put the Java into a sandbox, into a Java virtual machine that runs beside on the side of the module, if you like. In C, that's not possible. C, as far as I know, can't be run in a sandbox. It would run on the host CPU on the module, and that would make it more likely to cause problems for the module. So Java is a nice middle ground.
Absolutely, and we are licensing the official hotspot implementation from Oracle. And I think one person from Oracle once told me that This is also why we chose Java, I guess. Java is the single largest developer community in the history of IT. So every student basically nowadays knows how to program Java. So it's a really broad developer community out there, and it's an open, proven software framework that's relatively flexible and offers those advantages, as Simon has explained, with the sandbox that doesn't interfere with approvals, which you have to think about, of course, when you're building mobile and cellular IoT solutions. I'm checking if there's any other questions from you guys out there to us right now. Doesn't seem so for the moment. So as I said before, if you have further questions, do join our Gemalto IoT developer community. It's free. You find all the tools, you find code samples, knowledge base, articles you can exchange with your peers. You can ask questions to the moderators, and reach out to us if you have any more questions. And I'm checking one more time if we have any more questions in the Q&A. If not, I'd like to thank you guys for joining the third Global Intel IoT DevFest. We're very excited to be a part of that. I hope you enjoyed the presentations by Simon and Jürgen in Berlin, Germany. Thank you guys. It's amazing what you do. It looks so easy when you do it. Definitely have some mastery for our tools. That's great. Just maybe a sneak preview. There's going to be a new SDK tool coming. If you're eager beta testers, do let me know. Reach out to me, and you can be on our beta test program. That should make developers' lives also a lot easier. Java SDK, that is. Also thanks to Jose for joining us and explaining about the lifecycle management, all the different aspects that you need to consider, and being able to update your things in the field is definitely a good idea. And Jose, reach out to him. He can let you know how you can make this happen. You don't have to worry about this, and you can focus on building your application. So with that said, thanks a lot for joining, and hope to see you on the Gemalto IoT developer community soon. Thanks very much, and do visit us online. Take care. Bye from Munich.